Alright, guys, I'm sorry for the abrupt change of plans. I don't know what's going on with me. Um, anyway, let's get into it. We're starting the manual transmissions module in CDX, so it's AST 106, and this is ASC number 3, manual transmissions and drivelines. So we're going to pair this with the automatic transmission, which will come right after this. That'll be the next mod. There's no way we can speak about one without speaking about the other, so this will kind of be more of a 2 month long giant mod. And then, specifically with manual transmissions, we always group together drive lines. So it's going to take about an hour for me to explain the manual transmission. So this is the part where we add in transfer case differentials, things of that nature. And then when you go to take that ASC, it'll all be in with manual transmissions. So specifically this week, we're going to talk about the clutch. I want to begin and end this lecture with this video. This guy right here. So this says miss shifts. I'm going to ask you now what it means to miss a shift. That looked expensive. And then at the end, I want you to be able to explain what it means. What is actually happening when these guys miss their shift? Can you do it in your automatic? Can I do it on my motorcycle? And of course, these people are all doing it in their H-pattern manual transmissions. You ready to watch this guy die inside? No, you go. No, you go. No, you. Maybe we'll go together. Check out the flames on the side of that. What is that, an eclipse? Oh, it hurts. Dang. Yeah, you should be upset. Wow, I'm not letting you drive my car. Alright, we'll come back to that. So let's take a look here in ASC number 3. Your course ID for this module, 7A3774. Write it down. 7A3774. Pause the video. It's a video. You can pause it. And then when you get in here, like I have done previously, I've put under announcements the lecture is here, week 1 lecture, attached Word document so that you can follow along. And then I asked you guys at the end of the last engine mechanical class that we did about what your first engine you worked on was, and I got a good response. So I'm going to do that again this week, and here's the plan. Let me go back so you can see it. Yeah, that's not what I want. So when you get into ASC 3 at the top, announcements here, instead of hitting week 1 lecture, go to week 1 discussion. And here's my questions. Pick one. Here are the instructions, guys. Pick one of these questions and then text me your answer by no later than Friday at 5. And this way you will receive attendance for the week, which is like the biggest part of your grade. It doesn't have to be long. Just give me your thoughts. Pick something from here and answer me. I put my number in here, and there's no excuse why you didn't get it done. In addition to that, the good news is this module is rather short. 1, 2, 3, 4, 5, 6 chapters, and each one is really short, so this won't take you very long. Alright, that's enough about that. We'll come back to that in a moment. Where did I put? I got so many moving parts here. The first manual transmission was created in what year? Who knows? Raise your hands. Thank you. Alright, you in the back? Yes. Obviously not 20. Oh, look. 20,019? The correct answer is going to be 1877. And really, that question should be which came first, the manual transmission or the automatic? And hopefully, you all know the automatic came second. The manual is also referred to as the standard transmission because that was the first one that came out and that came in every car, and that was the standard option. And then later, when we came out with an automatic transmission, you could upgrade and pay more. It's interesting now, less than, I know it's less than 5%. I want to say it's 3% of the new cars sold last year in 2019. Only three, don't quote me, but I want to say it was 3% came with a manual transmission. And it hurts my soul a little bit when you see 18 wheelers advertising on the side, hey, we need drivers, must be able to drive a manual. If your job is to drive all day, how can, and I get it, a lot of you may not have driven a manual yet. They're slowly going the way of the dodo. Um, Now it's hard to find a manual, and those usually cost more, which is funny because a long time ago the manual was the standard cheaper option. And you know what I want to do before we go any further? I want you to name off all the transmission types that you can think of, and then count along with me because I believe there's five. So go ahead, I'm waiting. Yes, very good. All right. So we have the regular H pattern manual. We have a sequential manual, which is not the same. We have the regular automatic. We have a twin clutch. And we have a hybrid. Oh, and we have a CVT. So I'm up to 6. Yeah, and we're going to go over all of them, so hope you're ready. The two manuals in there, the H pattern and the sequential, most of the transmission is all the same. The difference being how you shift that one. So, for example, my motorcycle has a manual transmission with a clutch, so a lot like your manual transmission in your Civic, or what it. Chris, is your Challenger manual? I bet it's not. They barely make. Anyway, who else has a manual? Remind me next week. Who else has a manual? So the that's all the same. The difference being I can't go from first to fifth on my motorcycle. I physically have to go through third, fourth to get to fifth. The CVT, if you've had the misfortune of driving one, nobody likes them. And you know what? We really shouldn't be so hard on them. I'm going to talk about that more in automatics. Hybrids are pretty clever. A hybrid is, most times, it's a CVT with the added hybrid components. And if we took a hybrid car, so your hybrid Camry or your Prius, what part of it is hybrid? Actually, the transmission. So the engine is a regular engine. It's the transmission that makes that car a hybrid. And we'll talk about that more. Um, and the dual clutch, I have a question about this. Is the dual clutch transmission? I know you've heard of this. I've never driven one. Right? These are kind of exotic cars. Some lower end European cars, but most of the time, if we're looking at Porsches and Ferraris, they now all come with twin clutch transmissions. Is that an automatic or a manual? What group do I put that in? Things to think about as we go through this. Anyway, let's keep going on page 1 here. The definition of mechanical advantage is definitely the Terminator answer, that's for sure. Creating more force using math, I like that. So we know that is the amplification of the output force by trading distance moved for greater output force. If a drive gear has 10 teeth and the driven gear has 30, what is the gear ratio? Do you know the equation? Because you will. That correct answer would be 3-to-1. A key difference between a flex plate and a flywheel. We've heard these terms. I thought they were similar. They are. The difference being that the flywheel has a friction surface. Otherwise, they're all the same. Well, nobody has a hydraulic coupling. That's not what that is. Which of the following components is completely made up? Which one of these did I just completely... Yes, the bias ply inclination deflection meter. I do not have one of those in my toolbox. But in case any of the other things A through C seem alien to you, you might want to pay attention as we go through these lectures. Some manual transmissions are electrically shifted and may appear to be automatic. Is this true or false? This is true. My example is when Toyota came out with the MR2, they wanted to put an automatic in it because, let's all be honest, who was that car targeted at? Your dad wants a big giant V8. When you were a teen, you wanted a race car. Maybe it was like a teenage girl. Like, that's who, Toyota's very targeted. Camrys are for middle-aged women. Lexus GS are for middle-aged men. The Tundra is definitely for your dad. And the MR2 was for young women, and they thought it needed to come with an automatic. But that car was so tiny, and you guys remember they put the engine in the back. Well, mid, right? MR2, mid-engine, rear-wheel drive, two-door. So they stuffed it back there, and there wasn't room because automatics are always bigger than manual transmissions. So they came with this workaround. It was technically a manual transmission. There was no clutch lever, so it would actuate the clutch by itself, and unfortunately, it sucked. I've never been in one and had a happy ride. They're just sloppy, and let's be fair, this was 20 years ago, so the technology's come a long way, but they're not fun. The definition, the ability to be a solid while under stress, to flow or become thin in order to lubricate properly, describes which term, and it should be the only one on here that you have not seen before. Viscosity, we know we're talking about, is normally, we talk about oil. What oil weight is it? 5W30, 0W16 is the new sound. We're irritating. You couldn't have rounded that to an even number. 20 was better. Anyway, tensile strength is when you try to pull something apart. I hope you remember the word hygroscopic from any time I go to talk about brake fluid or the desiccant in the HVAC system. So the word here is thixotropy, and it's on here because it was on my ASE test and I had no idea what it was. So I'm trying to do you a solid, and you've seen it, maybe you'll remember it. Let's get down here to page 2. The book starts off with power flow, and I'm going to skim through this because I know you guys have this down. When we talk about power flow, we're going from the engine and we need to get to the drive wheels in whatever configuration that may take. So the engine has a limited range that it can operate. Wherever it idles, so look outside on the driveway, what do you got outside? It probably idles between 800 and 1200 RPM, right? And then where's red line? So the rev limiter hits between 5 and 8,000 RPM on most of our production vehicles outside. If we only had one fixed gear ratio and we wanted the vehicle to move quickly, and I want you to think about how much force and work, and actually the word here is torque and horsepower. Last time you had to push a car, like how much work did it take to get that bad boy moving? But then once it was moving, it wasn't so hard, right? So this is important that we remember this, especially when we talk about gear ratios. So getting it moving, we need a million pounds of torque. Actually, not a million, but we're going to need a whole lot of torque at the wheels. So we need a low gear ratio in order to multiply the force, Luke. So up here we talked about mechanical advantage is trading the amplification of output. So we're trading distance for greater output, and it thus makes sense. Any vehicle you've ever been in, first gear accelerates much more quickly than sixth gear. However, it doesn't go very far. First gear, you've got to shift out of and into second, maybe 10, 20, 30 miles per hour, because we've now gotten to the top of the rev limit of the engine. If we are on the highway and you want to race and you pull up next to me and I'm in sixth gear in my Blueberry and I don't downshift, I just leave it in sixth, I get absolutely no acceleration because this is the other end of the spectrum. However, sixth gear will carry me from 40 miles per hour up to, I don't know, maybe 110 or 20. I have no idea what that car does. You see my point here, though? First gear was 0 to maybe 20, but sixth gear is from 40 to maybe 120. And so what we're doing is we're trading distance. So when you hear somebody say, I put shorter gears, they don't necessarily mean the gears that came out of it are shorter with a ruler than the other. That means the gear ratio that we have achieved is trading some distance for greater force. So that being said, we've got to have a selection of gears if we're going to achieve a high speed. So if we only had one gear and you had to pick a gear, I want you to go back to when you were a kid and you had a bicycle, or maybe your friend had a bicycle, like a 21 speed, or just not a fixed gear, more than one, right? And so you would put it all the way up in the highest gear, right? Because that was supposed to be the fastest one. And then you would stop, hop off of it, jump back on it, and then try to push. And it seemed like, man, the top gear is the hardest one. Well, that's not really what that was. You're supposed to be moving before you shift into that gear. Like, you don't want to take off in your car in sixth gear, right? Same thing with the bicycle. So we're going to have some selection of gear ratios. And then once we've manipulated this gear ratio, we need to get it from this transmission to wherever the drive wheels are. So traditionally we have a rear wheel drive vehicle, so engine, transmission, drive shaft to a differential. And who remembers the main purpose of the differential? We're going to talk about it a lot in week 3, is to allow the wheels to turn at different RPM when we take a corner. You know that when you turn a corner, the inside and outside wheel don't go the same distance, therefore they cannot be rotating at the same speed. Otherwise you get that real groovy wheel hop. So if you feel a need to demonstrate this, jump in your four-wheel drive, turn it sharply to the left, shift into four-wheel low, and then try to walk around the parking lot, and I guarantee you those wheels will hop. But don't do that in real life. You might snap an axle. But anyway, so those are the main components. We have to have an engine, we have to have some selection of gear ratios, and then how we're going to get it to the wheels. I like this question. What's the difference between four-wheel drive and all-wheel drive? In both situations, I have an engine, I have a transmission, and all of the wheels on the vehicle are receiving power. So, is there a difference? And if you remember, we went over this in the intro course. The traditional answer is it depends on which way the engine is mounted. So, if we take a Jeep Wrangler and it's got a longitudinal mounted engine, right? So your traditional rear-wheel drive vehicle, where the engine is, the front of the engine is in the front of the vehicle, as opposed to a front-wheel drive transversely mounted engine, the front of the engine is in the passenger fender. So traditionally, if the engine is mounted longitudinally, that creates a four-wheel drive. And then if the engine is mounted transversely, so if you need a reference, and I'm going to show you when we get to drivelines in week 3, but like an Evo does this, a bunch of the Nissan, I think most of the Subarus now, the engine is mounted transversely with a transaxle right there in the driver's side of the front, and then it just has a third drive shaft coming out of the transmission to go to the back. So that's one definition. The other is whether or not you can disengage it. So if we get in that Wrangler, we go engine, transmission, transfer case, and the transfer case has a drive shaft that goes backwards to the rear diff and a drive shaft that goes forward to the front diff. And that transfer case has several gears. It'll be neutral, 4 high, 4 low, and 2-wheel high. All-wheel drive vehicles normally do not have a means by which to disengage. So that lack of transfer case is another way you can look at it. I'm not going to fight anybody about either way. I really don't care. But you might see this on a test question, and I'm trying to drive this home with you because ASC is so old that the correct answer on ASC is going to be it's four-wheel drive if the engine is mounted longitudinally, and all-wheel drive if it's mounted transversely. But then when you go to talk to your friends, there might be a different definition, so just be aware. On this little diagram I've got here, rear-wheel drive layout, I want you to look at it for a second. Just looking here, how do I know that this transmission is an automatic? It has one component that we will not find in a manual transmission, and that is this torque converter. So your difference between, number one, your difference between a manual and an automatic is the way that this engine and this transmission disengage. Uh, so the second thing that makes a manual and not an automatic is the type of gears within it. So just remember this for later, but an automatic has planetary gear sets and a manual has compound gear sets. And then it doesn't matter what kind of transmission, the engine will be the same, final drive will be the same. But a little trick there. And does anybody know what a sequential transmission is? I alluded to the fact that my motorcycle has one, and if you look up any real race cars, track cars, all the rally cars have sequential transmissions. And the beauty here is that there's no synchronizers. So you don't technically need the clutch to shift gears. And you can do it under full engine load. You can do it at high speed. It's not going to hurt the transmission one bit. So if you watch the sport bike guys launch from a red light and they go wop, pop, 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 oh my god, he shifts so fast. Well, he's not pulling the clutch in. That bike doesn't need it to. And then this is why, if you go watch those Gymkhana videos, Ken Block always has a sequential transmission. So there's just a stick sticking up in the middle of the car, not the handbrake, but the shifter, and it doesn't go left and right like your normal H pattern, right? So our normal first is the top left, and then we go down to 2, and then 3 we have to go right and up, and 4 will be down, and then so on. And a sequential, he just goes forward to go down and pulls back on it to go up, just like my motorcycle. And it creates a stronger, simpler transmission. The downside being, if we're in traffic and suddenly somebody stops in front of me, I push the clutch in and throw my transmission in neutral, I can go from fifth to neutral. It's not a big deal. And then we start rolling again, and really I need second gear now, so I can go from neutral to second, or I can go any other way I want. But in this sequential, that's impossible. You can't get to second without downshifting through fourth and third. And then if you hit neutral, you have to go all the way to the bottom and find it. So just things to think about for now. Let's talk about this for just a moment, and this is preluded to the fact that there's a hydraulic circuit in here that I really want to get into. But again, for your ASE, because these are ASE questions for whatever reason, your 3 different kinds of lever, it's all about where the fulcrum is. So which one of these is your clutch pedal? Because the pedal itself is a lever, right? Or jump on a motorcycle and the clutch lever is literally a lever. So which one? Does anybody want to take a stab at this? It says grocery bag here. I like it. That is he should have like 10 of these, because you know we all try to bring the groceries in one trip. Alright, so let's pick the car. That's going to be second class lever. We have a pivot point here where the clutch lever is mounted to the firewall. You push on the bottom of it where the pedal is, and it pushes the rod. Your brake pedal's the same way. It pushes the rod here in between the two of you. And then this is a great example here. This end where your foot is travels a much greater distance than this does, right? And the effect is that it multiplies the force. The force, Luke. One more time, we're trading force for distance. And then down here we've got great examples of the same thing. One of these travels much further distance, which may be useful for cutting your goat or trimming the lawn. And one of these creates much more force than you can apply. Great for... Dude, I use these dikes on everything, to be honest. But either way, so on this one, more distance, right? And this one, more force. We can't talk about transmissions without talking about gear ratios, and I want to get this out of the way while you're still awake, because you got to remember this equation. Excuse me. So gear ratios utilize mechanical advantage. Remember in our discussion of horsepower versus torque, we said that we can change the torque by manipulating the gears. And I have a video I'm going to show you when we get to week 3. I have this video of a Tacoma and he's got a few reduction gears. And you may have heard that when we talk about your starter has a reduction gear. The way that your starter, I know you've seen a starter, they're not that big. The way that itty bitty starter is able to spin your engine at 1200 RPM, which would be flipping impossible if you try to do it by hand. I know you can start the lawnmower, but that's like a zero point 0.1 cc engine. I'm sorry, zero point 0.1 liter, 1 cc. It's a little bitty engine, but your new Dodge Challenger Chris outside with a big old giant Dodge engine is flipping heavy and difficult to spin. So there's no way by hand to be able to get it done. And the way that this works is by a reduction gear. It's all the same principle. First gear is the same thing. We're trying to take the limited amount of RPM, shrink it down, and create way more force. So right here, this is the part I need you to remember. Driven divided by drive is the equation. So anytime we have two gears, which that's what gear ratios are, right? We've got two of them, and I'm trading force for distance. So one of these is not going to spin the same RPM, right? But if it spins less RPM because it's smaller, it will achieve greater force. And the way we find this out is driven divided by drive. It doesn't matter what gears we ever talk about. If somebody, and every test question is going to be written this way. If I have a ring gear of X and a pinion gear of Y, and the driven gear is the pinion gear, then the gear ratio will be, there's all the information you need. I need to know what the driven is, I need to know what the drive is, and then just remember it's driven divided by drive. So for this example, if this guy is being driven, number B, yes, and then number A is the drive gear, it's just 25 divided, I'm sorry, driven divided by drive, 75 divided by 25, which is a clean 3. And then because it's a gear ratio, so don't get your answer wrong. Going 75 divided by 25 is 3, because 3 is not the correct answer. 3 to 1 is the full gear ratio. So make sure when you write your answers down that you write a proper gear ratio. So 3.1 or 3 to 1. I see I'm doing it now. All right, before we go any further, I know you're talking about making a drag car. You got one in the garage you're building, and then somebody says, oh man, you're going to make it a drag car. You should change the gears in the final drive, which is your rear differential. You should put in 411s. What does that mean? How do we figure out how many gears are on the two teeth here? What are on the two teeth? How many teeth are on the two gears here? So your stock Camaro would have come with 373. So 3.7321 gear ratio. And then you want to change it because you want to go faster on the drag strip. So you put 4.1121 gear ratio rear end in it. And what will happen now is you will accelerate much faster and you will lose top end. You will not be able to achieve a high speed because you've traded now greater force for less distance. And people do this on their bikes all the time. You may have heard somebody say, I'm going down a tooth on my front sprocket or my back sprocket or whatever, and it's literally the same thing. So if you're thinking about messing with your vehicle, remember that if you want greater gas mileage, fuel economy, you want that number to go down. So a 3.73 to 1 rear end will achieve a higher speed. And then here's the main goal. What are you doing? You going to work? Is this your daily? You spend most of that time doing 70 miles an hour on 35. All right, what RPM do you want the engine to be at while you're doing 75? You don't want it to be 4,000. I had an Integra once with, I think it had 5 gears. And at 80 miles an hour, that bad boy was at like 4,500 RPM, which means it got terrible fuel mileage. The new Genesis that I was in not long ago has 12 forward gears, okay? So that means the gear ratio in, 10th or 11th gear at 80 miles an hour is so low that the engine was at 900 RPM as I was doing 80 miles an hour. That's insane. Now, if I tried to accelerate and I didn't downshift, it would go so slow, right? It wouldn't go from 80 to 85 very quickly. The flip side being, if I can do 80 miles an hour at 900 RPM, I'm going to have phenomenal gas mileage. So things to consider. And then when we look at vehicles, why did this come with that Integra? Who were they selling Integras to? Young kids, right? Not people in a luxury vehicle. So did 19-year-old me care that I was getting 20 miles to a gallon? Absolutely not. Um, that Genesis with 12 forward gears, does the person who has enough money to buy a Genesis, do you think they know and care about fuel economy? Probably. So when we talk about your Mustang or your Eclipse or whatever you're into, when they designed it, there was a reason they chose those gear ratios. And a big question is, what are you going to do with it? So my student Tony likes to go off-roading in the woods. He's going to need a complete different set of gear ratios in the transmission, the transfer case, the final drive to get his engine RPM where it makes the most power, right? And usable for what he's trying to do. And then let's talk about, oh, Chris was telling me a story about how he was doing 400 miles an hour in the new Challenger. So if he wants to keep doing that, salt flat top speed runs, he's going to need a different approach, right? And if you need a good example, I know you guys all have Forza or Gran Turismo, and they will both let you mess with the gear ratios. So I encourage you, while you're playing video games this weekend, why don't you go mess with them for once and then understand what you're doing to it now. See what happens if you give it a really short first gear and then a really long second gear and how terrible it is to drive, or vice versa. Or go mess with the final drive. Just have fun with it. But I want you to be thinking about these gear ratios. And then please remember this: driven divided by drive. And then you'll be good. So whip out your calculator. I know you have one on your phone, or you're on a computer or tablet that came equipped with a calculator. So I'm going to give you 3 examples just to make sure you're following along. The drive gear has 5 teeth. The driven gear has 65. What is this gear ratio? Let's do it all together. He said the equation was driven divided by drive. So driven is 65 divided by 5 is 13, right? So this would be 13.021. Make sure you write it that way with the little semicolon. 13 semicolon. Let's put the 0 in there, make it mathematical. 21, right? And then 27 divided by 3 is 9. So this next one would be 9. You like how I did these where they all ended in an even number, which doesn't happen very often in real life. 12 into 204, or 204 divided by 12 is 18 or 19. I don't have my calculator out. You guys double check me and then tell me. But I'm almost positive it's 18 or 19. It's been 2 years since I wrote this, so leave me alone. Alright, let's go to a real life example here. That 411, and look, I wrote it wrong a year ago. 4.1121 rear end is how it would actually look. So the famous rear differential swap that you're going to do from your 373 to a 411. This is interesting, I like this part. This could have 44 ring teeth and 11 pinions. So driven 44, right, on the ring gear, and then drive of 11. It could be 44 and 11, or it could be 52 and 13, because both of those equations come out to an answer of 4.11. Which one should you put in your car? There's no telling. Really what's available and what fits, but this is important, and I like this. I saw a tech do this. That's what kind of inspired this portion here. When I was a very young tech, I worked with a guy, and he was a transmission guy, and he would scatter these transmissions across the table, and magically they'd get put back together and run, and it was just the most amazing thing. He wouldn't label them, which I always thought was foolish, and there was a big giant pile. And then we used to, you remember my stories about Cisco. We used to go try to mess with him. So we would take other gears that we would find around the shop or whatever, and we would go like wash them up, or purposefully make them look dirty and throw them on his table and like just kind of hide them, camouflage them in with his other gears. And he always could tell what fit and what didn't. And later, right before I was going to quit that place and go to somewhere else, I had said something to him about it, and he was like, it's this simple. It says first gear. I'm just gonna make these numbers up. It says first gear right here in the book has a gear ratio of whatever, right? It'll be really low. No, I'm sorry. First gear will be pretty high. Um, it could be like 6.7 to 1. And he was like, I just take two of them that come out to 6.7 when you do the math, and then I put them over here, and that must be first gear. And then second gear has to achieve a gear ratio of, because it's just one division. Anyway, I thought that was cool that, God forbid, you did organize them and somebody bumped into your table and screwed it all up, and oh my God, how am I ever going to tell I didn't label them? It's just a little bit of math there. You can handle it. And the other thing that is nice about this is if we know what the engine horsepower and torque are, we can use this gear ratio to find out what amount of torque is actually getting to the rear wheels, which is really cool. So when I do on week 3, when we show the Tacoma with the step down gears, I don't remember exactly, but there's something insane getting to the rear wheels of this Tacoma, and I think it's like 5,000 foot-pounds of torque getting to the rear wheels. Now, that vehicle is not doing more than 10 miles an hour because of the way he has these gear ratios set up, but it is pretty cool. And let's go this real quick. Um, if I say the word shaft, that means what are the gears on? And then the gears or sprockets are fixed, clipped, or bolted onto the shafts. In any transmission, we have to have gear sets. So any transmission I speak about, when we say first gear, it's not one gear. It cannot be. A gear ratio is a combination of two gears, and we've already been over the equation, right? So that being said, transmissions will have at least two shafts, primary and secondary, or however they label them, so that we can accommodate these two different gears. And so in this one right here, if we were going to say first gear, it would be these two gears. And right now, I want you to walk away from the notion of first gear, second gear, third gear, fourth gear. And we're going to do it like the artist formerly known as Prince. The gear ratio that you used to call first gear is actually whatever gears. And it gets even more complicated in the automatic transmission with planetary gear sets, because those planetary gear sets never disengage, which is a tricky little thing. On our manuals, what we're talking about today, if we have 6 forward gears, there will be 6 sets of 2 gears, and when I shift the transmission into the gear ratio that we like to call first gear, let's just say, for example, these 2 gears get meshed together, my input gets changed because of this gear ratio, and now the output coming out of the transmission is whatever gear ratio, right? So that's important to know. There's no such thing as first gear. And when we get into the automatic and you put it in drive, there's no gear in that transmission that is drive. There's a combination of gears that achieve drive first or drive sixth, or the Genesis drive 12th. And then the way we approach reverse is a simple thing too. In many, many vehicles that are manual, your manual H pattern, reverse is first gear, except swapped the other way. And that's part of why you can't go real fast in reverse, which you really shouldn't be doing unless you're doing some crazy stunts. Send me a video. Don't do it. Don't do it. Alright, of these two, they're on here because these are test questions. Spur cut gears on the left here and helical on the right. Which one of these is stronger? Is going to be the spur gears here on the left. You see they have straight edges and these are cut at a 45. The trade-off, I said these are stronger, which means they are louder. They have a tendency to kind of clank together, make a little bit of noise. These helical gears will shift faster. These will mesh faster, and they cause less noise. However, they're not as strong. So let's take 2 applications. You got a brand new Dodge Viper, and you're taking it to the drag strip. You're hoping that all the gears in that car are spur cut. And your mom just got a new Honda Pilot, and we all know she wants it to be nice and quiet, so we're hoping, and this is like 100% accurate, that it will have helical cut gears. If you're rebuilding, so maybe you're really into Mini Coopers and you're going to build a Mini Cooper rally car and you've got the transmission taken apart and you're thinking, all right, man, we're making lots of power. I like the way the car looks, but I keep blowing the transmission up or I keep having problems. And hopefully you will all get to this point somewhere in your life, because I know we all want to build race cars where you get to come back and remember this. But a big upgrade is swapping from these helical cut, which came from the factory because they're quiet and they're reliable, to spur cut gears, which are way stronger. At the trade off of the car might be a little bit noisier, but what do you care? It's a race car. We can't even hear it over the exhaust anyway. And the same thing here, these are, when we talk about a ring and pinion in your differential, so that's what both of these are. And this is easy for you to understand too. When we go from the drive shaft to the rear differential, we're trying to turn that rotational energy 90 degrees, right? We're going straight back in the drive shaft, and then now we're going to hang a right and a left to go to the rear wheels. So I need to turn 90 degrees, and that's what these two do. But the same thing, you can have helical cut on the right, or you can have spur or straight cut here on the left. And then the same things all apply here. Alright, now we are in the clutch. I want to pause there for just a second and show you guys what we were up to this weekend. Check this out. Make it bigger, make it bigger. I am so jealous. I want to go ride one. I don't have a dirt bike yet, but that's my boy. That place looks awesome. You guys get dirt bikes, I'll meet you out there. I'm gonna be the first one to break their neck doing a backflip. Anyway, back to the clutch. The reason I've gathered you all here today. So, the clutch serves one main purpose. Who can tell me what it is? Why does the car have to have a clutch? The car doesn't have to have a transmission. We could hook the engine up to the rear wheels and go, and it would be fine. It wouldn't go very fast, right? Your fixed gear bicycle, your BMX bike, it didn't have a very high top end, right? Why do we have to have this clutch? So my experience has been, when I ask this question, people say to engage the engine and transmission, and that is so close to being correct, but it's wrong. I can bolt the engine and transmission together and they'd be connected, not a big deal. The problem comes when this happens. I want you to think. The vehicle's moving forward, we're coming to a stop. The wheels reach an RPM of 0 RPM, right? We're at a stop sign. The rear wheels, the front wheels, whatever the drive wheels are mechanically connected to drive shafts or axles, right? Those are mechanically connected to a differential, either in the front or the rear. That is mechanically connected to the output shaft of the transmission. We go through the transmission, whatever gear we're in is mechanically attached to the input shaft of the transmission. Now we get to this part. If that all comes to a stop, the wheels have come to a stop, so the axles, the differentials, the transmission input and output shaft are at 0 RPM. If the transmission was bolted to the engine, what is the engine RPM now? 0. And that would be a problem if every time you wanted to come to a stop, the engine stalled, or every time you started the car, it wanted to pull the vehicle forward. Cody was at my house not long ago, and we're trying to rotate his engine, and he's got a manual Civic, and he left it in first gear because it was on a hill, right, like you ought to do. But we go to rotate the engine, and it's really hard to do because it was still in first gear, so it's literally trying to pull the car. There is now a mechanical connection trying to pull the car forward. So the main purpose of this clutch is really to allow the engine and transmission to disengage. I don't always want the engine RPM doing what the rest of the driveline is doing, and really the best example is coming to a stop. The truth is, once you get rolling, even in your H pattern manual, you don't have to use the clutch to shift. All the new modern transmissions have synchronizers. If you know anybody that drives a big truck, 90% of truck drivers don't use the clutch after they take off from a stop because that clutch is really heavy. The same thing will apply next module when I ask you the sister to the clutch, the part that does this job in your automatic transmission called the torque converter. When I ask you what the purpose of the torque converter is, people will say it's to engage the inner transmission. And the reality is it's to allow them to disengage. So please remember this. This will help you as we're trying to get a grasp on the moving parts, how they fit together, and the scary part, how am I going to diagnose this bad boy? So we have to start with a strong foundation, and I really want to drive this home with you guys. The clutch is to disengage the engine and transmission. And here we've got a couple of pictures that I like a lot. How do you like this stripe on this one? Somebody took the time to paint, and then you're going to put the engine and transmission together and never see the cool paint job on this pressure plate. You know, it'd be cool if the rest of the car was painted that way, like driver's side was red and the passenger side. Anyway, so when you order a new clutch kit, this is what you get in the box. You get the clutch disc, and you know it's the clutch disc because it has friction material on it that looks very similar to the brake pads you guys see every other day. This pressure plate over here is very important. I'm going to get into that in a moment. It will come with a new throwout bearing. Now, I'm not great with terminology here. Pilot bearing, throwout bearing, there's two other names for it. I can't think off the top of my head. I know that there's a particular one, and I just mingle them all together. There is a bearing on the end of the crankshaft. There is a bearing on the input shaft, and then this bearing here. The one in between the engine and transmission, the one that actually actuates the pressure plate and makes the clutch move, I refer to as the pilot bearing. And the every once in a while I'll call it the throwout bearing. So either way, you guys be mindful because I don't want to give you misinformation. So when you're going through CDX, if it hints at it having a particular name for the answers on the questions, pay attention to it. And then when you guys come back after you're done to review for ASC, I will have what ASC wants to call it because I have that in my other notebook. But either way, moving forward. And then when you get a new clutch kit, it will come with this alignment tool, and we'll talk about why. It's just a plastic little guy that you'll throw away. Over here, this is the whole bad boy assembled. This picture has a multi-plate clutch, which is not common in most vehicles, but pressure plate here, flywheel here, clutch disc, and then pressure plate. And there's no bearing in this picture, but I will get into that. So we need to take a moment and talk about the hydraulic portion because I don't like going through this without it. And we've done this a million times. We're going to do it again. Any hydraulic system, Pascal's law says that if I apply force in a closed hydraulic system, pressure will be exerted everywhere equally. Super important here. So I'm going to draw, if I have my whiteboard, this is where what I would draw. I know you guys have seen it before. Ta-da! He's making a letter E. We're making a left turn. Anyway, hydraulic, and then we'll have. Let's do it again. We'll have different size cylinders. Now, on your vehicle, you have a master cylinder. What does it do? Everybody has a master cylinder. What's it for? It's for the brakes, right? When you push the brake pedal down, it moves fluid in the master cylinder. The clutch system operates in the exact same way, and in fact, many modern vehicles use the same master cylinder to achieve both. Older vehicles, you would have a master cylinder for the brakes, a master cylinder for the clutch, and two different reservoirs for the brake fluid. And then let me just say this. If you didn't know the clutch fluid, I'm doing that thing with my fingers, the bending my fingers thing. The clutch fluid, you can hear from my voice, I'm raising my eyebrow, is just brake fluid. It's, every vehicle is just brake fluid. Anyway, so they used to be separate on older vehicles, which makes more weight and more parts that can fail and blah blah blah. On all the new modern vehicles, the master cylinder handles both the braking circuits and the clutch circuit. And in either case, we've got over here, let's do some round numbers that are easy to do on the math here. We've got a 2, I cannot do this with my mouse, 2 millimeter, boop, bore, 2, I said 2, not a fish hook, 2, I missed my whiteboard, 2 millimeter. Over here, we've got a smaller bore, 1 millimeter. Those are seagulls, mind your own business. And 4. And you guys know that's 2 millimeters or 4 millimeters. All right, now, so this is going to be the bore of the cylinder. That means, you remember bore from engine performance. That is the inner diameter. So we're looking at it from the side, but because these are cylinders, it's a circle. Just pretend that's a circle and not a lemon. So the bore would be this distance here, right? From there to there. What size is this? All right, now we're going to apply some force. So we're going to apply force here, and we'll do a nice round number of 4, and we'll just keep it PSI. That's not completely relevant, but this makes the math easy. 4 PSI. Boop. And so we've got a bore of 2 millimeters. We're applying 4 PSI of force to the piston inside this cylinder, right? And it's going to travel. Let's change colors here. Let's get some red going on. It's going to travel. Hey, punk. I said red. You're a hooker. Anyway, I guess it's going to be black because I'm not doing it again. It's going to travel. Let's keep it simple. 2 inches. You know what's really messing me up is I have 3 monitors, so my mouse is not the same left and right as it is up and down because it's trying to span my 3 monitors. Anyway, now if force is applied equally in this circuit, it's going to act differently on these 3. If I apply 4 psi of force here, and we have an equal piston and an equal cylinder on this side, will it receive the same amount of force? Yes, absolutely. So this is just going to be the same as this one. It's receiving 4 psi of pressure, of force, because they're equal. And therefore, will it travel the same distance? Yes, of course, because it's literally the same. Now, this gets more fun. If it is a smaller bore, I have less surface area for the hydraulic fluid to press against. Is it going to increase the amount of force or have less force? It's going to have less, so we'll just divide. This is 1 is half of 2, so half of 4 is, this will end up only receiving about 2 psi of force. And because force and distance are tied together, therefore, is this piston and this bore going to travel further or less than the initial one? Well, we got less force, so what do you think? Let's talk about the scissors and the dikes again. What happened with that? If I've got less force, I'm going to end up with greater travel. So that fluid, I want you to think about this. That fluid has to go somewhere. I'm moving the same amount of fluid here as I'm moving here. But the bore that it's pushing against is half as wide. So it can't put as much force, and it will take more travel before I can use that fluid up. So if I have a smaller bore, it'll move further. And I was trying to think of an example where you would use a hydraulic circuit to do that, and I really can't. Every example I can think of is the opposite, which is the bottom one here. So in real life, your master cylinder and your brake calipers, or your master cylinder and the slave cylinder on your clutch, which is specifically what we're talking about today, we're going to do it this way. So this guy at the bottom that is twice as big in bore is going to have twice as much brake fluid pushed against it, which means it will exert twice as much force, which is great. You've got a really heavy pressure plate and you're trying to move it, and the springs are just really stiff. Well, the clutch pedal is going to move a lot, but in reality, this pressure plate doesn't need to move very much. So this is a great example of how we're going to use hydraulic fluid to create mechanical advantage. And because I received or exerted twice as much force, what's that going to do to the distance? It's going to reduce it 1 inch. Very good. So in real life, we're not going to have a circuit with 3 different ones, but I just want to show you this. And remember the other thing too, what's going to happen, since we're talking about this right now, what's going to happen if, where's my eraser? If I get a hole right here on your brake system or the clutch system, you're going to push the fluid and the fluid's going to go, well, I could keep going this way and push against this, which is hard, or I could just jump out the side right here, which is real easy, and we all know it's going to take the path of least resistance and the fluid's going to go pfft. All right, now when all that fluid leaves and the top of this reservoir starts to pull air in, you're going to push the pedal and air can be compressed, whereas liquids cannot. So you're going to compress the air, and then this guy isn't going to move and you won't have brakes, so you won't have clutch. So that specifically today with the clutch, if your clutch is acting funny and we suspect something is wrong, the first easiest thing that you need to check is to make sure that the hydraulic circuit is working as intended. And this slave cylinder is mounted most of the time on the outside of the transmission. So you could say, hey Timmy, oh you work with Bill, hey Bill, come step on this clutch pedal for me. Or really grab a porter, I'm sorry, where's my porter? Travis, come step on this clutch pedal. And while he steps on it, you can take your flashlight and look at where the slave cylinder is mounted on the side of the transmission and see it moving, and you go, oh yeah, it's definitely not that. Or, hey dude, this thing isn't moving at all. Alright, well the way I'm going to go about diagnosing this is completely different. And then I will end this video with a picture of my slave cylinder, assuming I can get to it. I said that before I thought about it. Mine isn't front wheel drive. Shoot, I don't think anybody in the neighborhood has a... What we'll do is week 3, we're all going to be back in the class, and I'm almost positive we can see the one on Cody's Civic. So remind me, we'll go out there and look at Cody's on week 3. Thanks, Cody. I just volunteered you. I hope you don't mind. Alright, let's get back to the lecture here. Automotive clutches are dry clutches, meaning there's no lubricant. And why did he say that? That must mean there are wet clutches. And there are. So I'm going to segue here for just a moment and show you. Not this. Not this. Stop. One too many buttons. Where's the go away button? There you are. Number 2. Here is a wet multi-plate clutch out of a motorcycle I've got in the garage right now. Why would it be wet? Well, it keeps it cool, it helps wash away clutch debris, it makes it quiet. All these reasons you might have a wet clutch. Most off-road vehicles, motorcycles, utilize a wet clutch like this. Some high-performance ones will have a dry clutch. And the trade-offs are the performance goes way up. Just think about these clutches here, and let everybody take your hands and rub them together, right? That's what we're talking about, is friction. I want this, pretend your right hand is the clutch and your left hand is the flywheel or something. I don't want them to slip. We all know what that means, the car slipping. I don't want that to happen. Well, if these clutches are wet, they're soaked in oil, there's the greater potential that they would slip. So an exotic motorcycle will come with dry clutches. The trade-off is if you get near a Ducati, you can hear that bad boy clack, 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 because those clutches are noisy. On the vehicle, we're going to always use dry clutch. And it doesn't matter if it's noisy because your head is nowhere near where this clutch actuates. I got another picture here. So in a multi-plate clutch, and then I'm doing this twofold here. Let me knock this out. This is called a clutch pack. That picture I just showed you is it all assembled. We use these in automatic transmissions and for limited slip in posi rear ends. So I want you to be familiar what they are and what they look like. It's not just because I like motorcycles so much. So here we see that these clutch discs have friction material, and these we call these steels and frictions. So the one with friction materials, the friction disc, and the one that's steel is called the steel disc. I know it's super complicated. Anyway, so these frictions have, what do we want to call these, tabs, tangs on the outside circumference, and the steels have splines on the inside. And to the right of this picture, you can see that some of them, namely the steels, will spline with the clutch basket. And you can't see it in this picture, but oh yeah, let's go back to the last one. And if we look at this one, oh, that's not a good picture either. It needs to show you where it goes in the transmission. Anyway, these that stick out will grab the outside of the clutch basket. And the idea being that one is input and one is output. When they get squished together, then the input and output will spin as one. And then when you pull the clutch lever in, it creates space. These guys are free to spin independently, and that separates input and output. So because they are friction material, they will wear out. It is possible that in your automatic transmission, these clutch packs can wear out over a very, very long time. If for whatever you're working on, four-wheeler, chainsaw, if it's got frictions and steels, you can 100% rebuild this bad boy very cheaply. These baskets never get worn, it's just the steels and frictions. My advice is if you're going to order new frictions, just get new steels with it. You can reuse them. They're supposed to be machined like a flywheel. They're not real expensive. This is a big dirt bike, so it has a lot of them, and I think I gave $60 for all of this. These are the old ones, but I have new ones. But $60, and he's going to be good for another 50,000 miles. It's just one of those things. Just do it. Best service possible, right, guys? Here it is. So this flipped upside down, but the frictions would go on the inner circumference of this guy here, and the steels will slide over the outside here and then be mated to that one. And let's see, I have one more. Oh yeah, and then because they're wet clutches, if you guys ever change one, when you get the new ones, you got to make a little oil marinade here. See, we got some spices and herbs, and really it's just make sure that you get your wet clutches wet for at least the night before you go to install them. Otherwise they could burn up prematurely, and that would suck. So tips from life. Not that I've ever done that. Anyway. Let's keep moving. So coefficient of friction, rub your hands together, that's what we're talking about. How well the clutch engages, whether or not the clutch slips, how hard it is to disengage the clutch, and how much the entire ensemble weighs are all things to think about. Your factory clutch, what properties are it gonna have? Well, it's gonna be quiet. It should last a super long time. It should be cheap to make. It will probably not handle a whole lot of horsepower. It will probably weigh a lot. It will probably be very easy to engage and disengage. Now let's flip this over and talk about your race clutch application. So you've been building a Dodge Neon and now it's got 800 horsepower and it just won't hook up to the transmission. So now we need to upgrade the clutch. Well, what things do you get when you upgrade the clutch? Let's talk about it. The new clutch disc will come with a different material on it. If it has a higher coefficient of friction, just like your expensive brake pads, if it does a really good job, it's going to be noisy. That's just all there is to it. So higher coefficient of friction, the springs on the pressure plates are going to have to be stronger because I'm trying to cram these things together to make a mechanical connection. But if the engine makes a whole lot of horsepower, it's going to want to slip. Or if it revs really fast, RX-7s are notorious for this because those engines spin up so flippin' fast that it makes the clutch want to slip. So I have to squeeze it like a sandwich really hard. That's going to require a very stiff pressure plate. That sucks because every time you go to push the clutch pedal down, you're having to fight this very, very strong pressure plate. Some other things are going to be, I now want the new assembly to be lighter. So higher quality materials, better machining processes means money, money, money. In this discussion, I fall back on Exetti clutches. You'd think I was being sponsored. If Exetti, if you hear this, what's up, bro? I always tell everybody, hey man, I need a new clutch. What should I look for? Go get an Exetti clutch. They're OE applications, and I've used up to the stage 2 aftermarket kits, are superb for the price. You can go out and spend $1 million. The Exetti clutches are always reliable, they fit. I'm all about it. So if you guys are thinking about burning up your clutch, check them out. Now let's move on to the flywheel. The flywheel and the flex plate. Let's talk about them. They are related. They are distant cousins. The flywheel goes in a vehicle with what kind of transmission? Manual transmission. The flex plate goes in a vehicle with what kind of transmission? Automatic. What's the difference? The flywheel has an area for friction material to mate against. So a mating surface. Ooh, boogie woogie. Right here, I've got two pictures. This one over here is. No, you're not. You're a dual mass. Somewhere in here, I could have sworn. Anyway, when we get back to the class, I have them on the table to show you. The only way you're going to be able to tell the difference, because otherwise they will look the same, is imagine that instead of this ring here, the mating surface, if it was just stamped steel. Otherwise, I have holes in the middle because I'm going to bolt this to the end of my crankshaft. I have teeth on the outside if you are ever curious where your starter is engaging to actually make the engine spin. It's these teeth here because this guy is bolted to the crankshaft. On the right here, this dual mass flywheel, if you've heard the term harmonic balancer from an older vehicle, that was the crankshaft pulley on the front of the engine that the inside had rubber or plastic or something to try to smoothen the engine out as it was spinning. And we really don't have those anymore. The crankshaft pulley's gotten smaller and smaller and smaller and is now just one stamped piece of steel. So some vehicles, let's talk about application here. This is going to be your Lexus's, Lexi, is that the plural? This would be your Volkswagens. These would be your commuter luxury vehicles. Are going to have a dual mass flywheel to try to smoothen everything out. And then your Sentras and Versas are going to come without. So me, race car, I want the guy on the left. If we're buying a vehicle for your wife, we want the one with the dual mass on the right. The pressure plate looks like this, back and forth of it. We'll notice here there's another mating surface. Look here, where my mouse is doing this little swirl. And look here on the flywheel, we have two mating surfaces. So these are the two pieces of bread in our clutch sandwich. And then, of course, the clutch goes in the middle. This area where the mouse is, these are the springs. They look like fingers, right? And there's an indentation right here on the inside that that's where the bearing pushes on this right here. So it's really hard to see and imagine the way that the pressure plate flexes. And when we get in the classroom, I'll show you. I can't do it by hand, but I'll stand it up and we'll talk about it. But the idea here is we've got this flywheel bolted to the crankshaft, right? It doesn't move. Well, I mean, it moves with the crankshaft, but this guy's the engine now. We've got a clutch disc This guy goes in the middle. Okay. And then this pressure plate is the other piece of bread in this sandwich. When your foot is not on the clutch pedal, the clutch is fully engaged, which means this piece of bread is squeezing that slice of ham into this other piece of bread, and the clutch is fully engaged, right? And we have a mechanical connection. So the bolts here from the crankshaft, mating surface here, transmits power to this clutch disc, transmits power to this pressure plate, and you'll notice on the pressure plate there's no splines or bolts. So this does not get bolted to the transmission. Instead, you'll notice the center of this clutch disc has splines. So flywheel gets bolted to the engine. These splines go on the transmission input shaft. Okay. If it's separated, flywheel can spin whatever RPM he wants, and the transmission's not affected. This is how we come to a stop. Transmission stops, the engine doesn't stall. Now you let the clutch pedal go. It comes to the top. The pressure plate goes back where it was, squeezes the clutch disc against the flywheel, and now flywheel is spinning. It's bolted to the crankshaft. Clutch is spinning the same RPM, and the splines here will transmit the power to the input shaft of the transmission, and then we have input shaft of the transmission doing the exact same RPM as the engine is. And this is really how this all goes together. The reason at the top that the new kit came with an alignment tool, let me find it again. Lord, I passed it. Chingo. One of these things is not like the other. Where did it go? Right here. I'm so stupid. Anyway, this alignment tool has itty bitty splines on it that are for this clutch. And you'll notice the clutch doesn't have bolts, holes anywhere on it, right? This clutch doesn't have bolts anywhere through it. This pressure plate down here gets bolted to the crankshaft. The pressure plate, this flywheel gets bolted to the crankshaft. This pressure plate, see these holes here? The pressure plate actually gets bolted to the flywheel. So they're spinning at the same RPM all the time. That clutch doesn't have any bolts in it. That clutch spline needs to go onto the input shaft of the transmission. So I want you to think about trying to assemble all of this without that clutch falling or sliding, and then when you have the task of trying to stab the engine and transmission back together, you've got to hope that this clutch didn't move. Sounds difficult? Yes, nearly impossible. That's why they sent this nifty little alignment tool. So really, let's walk through this together so that you're ready when you hit the dealership. You've taken everything apart. You've sent the flywheel to the machine shop to have it machined. It's come back looking pretty. And oh, also, since we're here, the rear main seal on the engine is right behind this flywheel. And let's just go ahead and, like, you should always try to upsell this and tell the customer, look, it's $30 for the seal. I'll only charge you 0.3 to install it. And it would be a shame if you just had your whole clutch rebuilt and then 20,000 miles from now the rear main seal starts leaking, because then I have to take all this back apart because the rear main is right behind the flywheel. So we're talking, what is it to pull in a transmission? Chris, you just did this on that Focus. It's no less than 6 or 7 hours. That Nissan I did, that Mazda I did, the book said 9 hours. So 9 hours for me to put the flywheel in, and then let's pretend 2 weeks later your rear main seal started leaking. It's another 9 hours labor to get to it. Or, hey, while I'm doing this clutch, let me get another 0.3 and I'll put a rear main seal in, which is exactly what we did to that Mazda. So anyway, okay, let me get back on track here. So we're going back together now. You put your rear main seal on. You got your flywheel either new or resurfaced. We're going to bolt right here the flywheel onto the crankshaft first. Nice. Then we're going to take this clutch, hold it up against the flywheel, and insert the alignment tool. And what's really groovy on the new ones See this itty bitty bearing right here? The itty bitty little bearing goes on the end of the alignment tool and goes into the thrust bearing at the end of the engine, right in the center, this big center hole here of the crankshaft, so that it holds this clutch perfectly straight where it's supposed to go. So, alright, you hold, you be still. Then we're going to slide the pressure plate on top, and the alignment tool will be sticking out of the center right here. And you'll slide the pressure plate on, you'll run some bolts in. Before you go to tighten the bolts, you'll make sure your alignment tool is nice and straight, and then you'll run those bolts down tight. Now, the pressure plate is sandwiching the clutch against the flywheel and it won't move. You can take your alignment tool out, the clutch won't move at all. Now when you go to align the transmission back up, it'll all go in nice and smooth. So don't skip that step, it'll save you an hour's worth of fumbling around. Alright, note the inside of the pressure plate on the right has a friction surface just like the flywheel, yes. Over time this will rust or wear out. The springs so these fingers, the springs will fail. They absolutely will. Older vehicles used a cable to pull the pressure plate. All the newer engines use a hydraulic system. I had a friend with a 2002 Mustang Cobra, or maybe 98 convertible top, and it had a cable operated clutch, and it sucked. It was really, really hard to engage and disengage the clutch because we're overcoming these giant springs and there was no multiplication of force happening. So the hydraulic clutches make this much, much, much easier. The mechanism by which the clutch moves away from the flywheel is the throwout bearing, and the release system is usually a fork. So what is going to make this pressure plate move away from the flywheel and allow the clutch to spin, and then therefore the engine and transmission disengage, is this system right here. So this diagram does a great job right here. Flywheel bolted to the back of the engine. Clutch plate sits in the middle. Then this says clutch cover, but this is the pressure plate. And the bearing gets pushed into the center of those fingers. The bearing pushes right here in the center. And it's this weird, it's rather difficult to explain. White. We want white. Give me white. Why do you hate me? What am I doing wrong? Who's good at GIMP? White. Okay. So, I'm going to do a cheesy little drawing here. We've got from the side. So now we're looking at everything from the side. Flywheel like this. Pressure plate clutch. Flywheel, clutch. And then we've got this bigger pressure plate that has these fingers. Okay. And then we have a bearing here. So let's go back here. Look inside this is the input shaft of the transmission this is all riding on. And it has splines right there that go to the splines right home. Okay, very good. So on this shaft we have this bearing. The bearing, when you are not pushing the clutch, the bearing is pushed away by these fingers. Okay. And in normal operation, that means that the friction surface, the mating surface, is pushing this way, squeezing the clutch against the flywheel. Okay? We're going to change color here. Now you push the clutch lever down. I want to disengage the clutch. You push the clutch lever down. The slave cylinder moves the fork and pushes the bearing into the fingers of the pressure plate. So this guy now in blue gets pushed this way, which deforms the pressure plate, this right here where my mating surface is, and actually pulls the mating surface back this way. Now, this guy isn't pushing the clutch, which is not being pushed against the flywheel, and I can now have a separation of engine and transmission. Then, so your foot is all the way down, right? We're pushing this throw-out bearing into the pressure plate. It's disengaging the clutch. You shift gears or you do whatever, and we're ready to re-engage the clutch. So you bring your foot up. These springs, let's change colors one more time. Try green. So now we're going backwards. The springs push back. That's why the clutch pedal comes back up by itself. The springs push the bearing back. This allows the pressure plate to, I don't want to say warp, but go back to its original position and push the clutch again. So when you're not in the vehicle and you've got no feet on the clutch, it's pushing. It's pushing all the time. It's always trying to be engaged, right? When you push the pedal down, that is when it actually separates, which is why you leave your vehicle parked on a hill in first gear and you walk away from it, and there's this mechanical connection here between the engine and transmission, and it won't roll. Now, when we talk about the torque converter and the automatic transmission, there is no mechanical connection. So you cannot leave your automatic transmission in drive on a hill. It will roll. This also is why if you have a manual car, you can pop the clutch to jump start it. Let's pretend your battery died. We can go push your car, you put it in first, drop the clutch. It will make the engine rotate. It will jump start the car. You can't do that in an automatic because it doesn't have this mechanical connection here. So we'll definitely review all this again, but let's make sure that I've repeated myself enough times. Excellent. So this fork here is just a simple pivot right here. This clutch release fork. There's really nothing to this guy. I've never seen one fail. There's some sort of clip to hold it against the transmission, and then a boot, does boot, to try to keep garbage out. Now as the clutch wears, this material here is going to start to be shedded. All that brake dust on your wheels, and well, this clutch is going to do it too, and it gathers in this bell housing of the transmission. So pretty please, if you swap the clutch, take a pressure washer or something and clean the inside of this bell housing out so that it's not full of. It would suck if that old friction material got on the new clutch and caused it to slip or something after you spent all day replacing this. So let's talk about wearable items. This clutch disc, is it gonna wear? Well, duh, it's a wearable item. It's friction material. That is gonna wear out, and that is the number one reason. Why isn't my clutch working? In my picture here, I'm squeezing the pressure plate, and it's pushing the clutch, and the clutch is pushing against the flywheel. But if there's no material left on the clutch, then I won't form a connection. So the number one reason is pretty obvious. The clutch is simply worn out. If the vehicle has 100,000 miles on it and the clutch isn't working, it's very safe to assume it's just been driven along a lot. If you know the driver slips the clutch a lot or has been racing, yeah, it's just, of course, it's worn out, not a big deal. Other ways we can have failures though. The springs, the little fingers here on the pressure plate can break. If they break off, there's a chance it could get lodged in the rotating assembly. Or if there's nothing for the bearing to push against, then it can't do its job. Right? Now, if that happens, if it breaks, it can't leave. It'll be in this bell housing making noise. And I want you to just imagine, let's take this pressure plate here and let's break half of the fingers off. That bearing will probably find its way in there and get locked up and jammed, right? It'll probably get pushed further than it's supposed to go. When that happens, it's a very obvious, oh my God, something is very wrong. So you'll be able to hear that. That is a rare thing. That's much more you've been racing the car. 90% of the vehicles are just going to be this clutch disc is worn out. The flywheel itself has mating surface on it. I've never seen one fail because that mating surface had gotten bad, but just like a disc rotor, like it's not going to last forever. But normally this clutch friction material is going to wear out way faster than the flywheel. And then you don't ever do this without measuring the flywheel. So nobody's going to put a new clutch in without measuring the flywheel and making sure it's safe to reuse in the same way. None of you are slapping brake pads on without checking the rotor. So I've never seen that happen. Interestingly, though, I have seen several times, this was a GM problem here. Outside of the flywheel, inside of the flywheel, and holes for bolts. Okay, just I know it looks like it's a bagel. It's an everything on top bagel, delicious. Okay, so I have seen this happen. We've got bolts in around here for the crankshaft, yeah, and we've got teeth on the outside for the starter, right? This will happen on a flex plate on an automatic transmission as well, but since we're talking about it, now it's a bagel with a mohawk. Anyway, outside rings, inside bolts, okay? And it will crack. It'll get a spider crack like this. And I've seen this. If you guys Reddit just rolled in the shot, we get one of these once a month on that Reddit, where it'll get a crack. So now the starter lives here and has a little gear that comes out to grab these teeth, right? So the starter is spinning the flex plate or the flywheel, but because it's cracked and broken, the inner circle here that is attached to the crankshaft isn't spinning. So I've seen this a couple of times where I can hear the starter is turning and something is spinning, but the engine is not starting. And that's 100% this guy right here. The thing that sucks about this is it's really hard to see because this flywheel, this is the transmission, but in between this transmission and the engine, you cannot see it. There's no looking at it from the outside. It will just have to be, I'm taking the transmission out to inspect it. I don't have a diagram here. Anyway, so that's the interesting thing. Alright, so don't tell anybody that you're watching an automotive instructional video, but just pause it here and then go get somebody and ask them, like, what do you think I'm looking at? Here, I'll draw some other stuff. Check mark, an X, some more seagulls. It's a vampire seagull. Arr. Anyway, stop goofing off. Now, the hydraulic portion we spoke about earlier, you're going to have the master cylinder on top. So this is a great picture here. This one is the brake master cylinder, and look back here in the corner, we've got another reservoir, so that means that's the clutch master cylinder. It's very, very simple. If you've never seen one out from the side, master cylinders are so simple. Here's the rod that goes to either your brake lever or your clutch lever. You push it this way, it pushes the rod in, compresses the fluid, pushes fluid out the ports, and then down the lines and wherever it goes. So there are seals on them. Yes, they can fail. It's not very likely. What's much more likely is that one of the rubber lines go into the transmission. So from this master cylinder on the clutch system is called the slave cylinder mounted to the transmission. And it could leak or the rubber line could leak. Absolutely. So here's a picture of a slave cylinder. This is super complicated. You ready? Master cylinder on the firewall. Slave cylinder mounted to the transmission. Hydraulic line goes in, and the other end of it is going to push. Who knows what's it going to push? This end of the clutch fork. So it's now that we're breaking it into small chunks, it's really pretty simple. You push the clutch lever down. Right here, the clutch lever pushes into the master cylinder, compresses fluid. Fluid leaves, goes down the line, comes to the slave cylinder. The slave cylinder pushes the release fork. The release fork pushes the throwout bearing or pilot bearing or whatever you like to call it into the pressure plate. The pressure plate deforms, that's the ASE word, away from the clutch disc. Now the clutch disc is not being sandwiched against the flywheel, and the crankshaft is free to spin. The input shaft of the transmission is free to spin, and they're disengaged. So from an overview standpoint, this is not very complicated at all. I put this guy in here. Some Nissans I've worked on have an internal slave cylinder, so this slave cylinder that's normally mounted exterior to the exterior has been on the inside here. And not that it really matters, it's going to all work the same. The problem is that when you go to pull the transmission away, it ruins this slave cylinder and you can't reuse it. So, just one of those things when you go to parts, I've diagnosed it, just needs a clutch, no big deal. Anytime you do that, I need a new clutch, I need a new pressure plate, I need a new throw out bearing. We're going to take the machine, they're going to take the flywheel, send it to the machine shop, and let them inspect it. If the slave cylinder is mounted externally, if it's not leaking, there's really no reason to replace it. If it is mounted internally, it must be replaced. So just make sure you find out before you go to the advisor with the parts list whether or not you can reuse it. God forbid that it turns out later when they approve the job that it has to be replaced and you didn't add it to the parts list. Now, who's going to come up with one? This happened to me. I did a Nissan Sentra, and I didn't know about this. I pulled it out. Oh, look, there it is. I couldn't figure out why there was the brake line. I'm sorry, I should say the clutch line. It's full of brake fluid. Leave me alone. It went straight in the side of the transmission. I couldn't find the slave cylinder, and when I separated it, oh, there it is. It's inside the transmission. It was way back here. That's groovy. Okay, whatever. And when it does that, it tears this boot. Like by design, it's supposed to do that. You're not supposed to reuse these. Oh Lord, I didn't. Oh man, now I got to price one out. And Nissan wanted $130 for it. Well, I didn't know that. Am I coming out of pocket? What was nice, and I'm gonna say it because I like to say it, the Exetti clutch kit that I bought. I didn't know it, but it had already come with a new slave cylinder. They already knew I was going to need it, and it was included in the kit. So I got lucky. Either way, remember all that stuff. Make sure that you find out before you go to price this stuff out. Now let's talk about some clutch problems. My clutch pedal makes a noise when engaging or disengaging. This is what everybody tells me. I need a new clutch because when I shift from second to third, it grinds. I want you to think about this. The clutch engages and disengages the engine from the transmission. And we haven't really gotten into the transmission yet. We're going to do that next week. But that has nothing to do with shifting gears. And I know the confusion because every time you shift gears, you probably push the clutch in. But I told you you don't have to. And you're more than welcome to call me and fuss me if you don't agree. When you go to shift gears, that's parts inside the transmission. And as we saw from this above, none of these components are inside this transmission. Now, I mean, yes, this is mounted to the input shaft, but technically when we talk about the gears, first, second, third, fourth, reverse, those are inside that transmission. They have nothing to do with this clutch. So when the customer states it's grinding or it's noisy when I shift from X to Y, that simply has nothing to do with the clutch. That's a lot like saying, hey man, when I hit the brakes, my steering wheel shakes, right? We call that brake judder. Therefore, I must need tires. Hold on. I know that in your brain, those are related. However, if we take a second, so this is important when you go to talk to somebody about transmissions because it's like the other thing too. My car won't start. I turn the key and I can hear the starter clicking, therefore it needs a new starter. No. The battery is dead. That's the starter solenoid clicking because it's not getting enough amperage. There's nothing wrong with the starter, but yes, you do hear it. So this is the same thing here. When you've got a noise, we need to find out when it's happening to be able to do this. So if it's noisy when you engage and disengage the clutch, that sounds like a clutch issue. If it's noisy when you go to shift gears, that is probably not a clutch issue, right? So we're going to diagnose and sell those things differently. In this situation we've been talking about replacing the clutch, I have no reason to go into the transmission. Let's do this manual transmission. You ready? We're going to rip it out. Number one, we're going to clear the way, so whatever's on top of it. Number two, I've got to get the shift linkage. That's the cables or bars that you connect the shifter to the transmission, right? Disconnect those. I need to get whatever mount or mounts hold that transmission to the car, normally one or two. And then all I got to do is get the bolts that hold the transmission to the engine out, and it comes right out. So I've done that. Now I can get to the clutch. I have no reason to go in this transmission. So my labor time is going to be vastly different if I do have to go into the transmission, because it really is the two or three or four gears that create whatever gear ratio you're having a problem with. That's going to require the entire transmission A, removed from the vehicle, all that labor, and then B, disassembled, much, much more labor. So this is super important we nail this down. The clutch pedal chatters during acceleration. So is this the clutch? Probably. What could it possibly be? A, it could be the friction material is worn out. B, it could be that the pressure plate is weak or broken. C, it could be that the flywheel mating surface has been scored, grooved, warped, any of those things. This is the beauty of this, and this is where I want to comfort and calm you a little bit, because I know we're going over a lot of stuff, but diagnosing this is very simple. If it is the clutch, the flywheel, the pressure plate, or the throwout bearing, there's no way to verify without removing the transmission. So I think it's the clutch. What I gotta do? Pull the transmission. I think it's the pressure plate. What I gotta do? Pull the transmission. I think it's the flywheel. What I gotta do? Pull the transmission. So even if I'm wrong, I still gotta pull the transmission. So there's if I think it's the clutch and it turns out it's not the clutch, it's the pressure plate, it's the exact same labor and you're taking the exact same parts off. So you really just have to be in the ballpark, if that makes any sense. We really just have to decide, is it the clutch system or is it inside the transmission? So that's part of why um, I'm drilling that into you. The clutch pedal pulsates. This will be a warped flywheel. This would be if it got hot, okay? So they've been racing, they're doing drag, so they take off from a stop and they're revving the engine at red line and they dump the clutch all at once. It gets super hot and then they stop the vehicle and don't race anymore. Then it cooled off rapidly or got wet or something. That would cause a pulsation to happen. The clutch pedal remains low, stuck to the floor, or spongy is all the same thing. We said there's a hydraulic circuit between the pedal, the slave cylinder, what actually moves the release fork. So if we get air in the system or the right, so if air gets in it because somebody worked on it, or the fluid has gotten low because of a leak and has introduced air into the system, we're going to have problems. So any vehicle, customer states anything about transmission, we're really going to do it all the same way. Number one, get in the vehicle, push the clutch pedal. How does it feel? Does it feel good? Yes? Okay, I'm not really worried about that. If it feels suspicious at all, we're going to diagnose the master cylinder, hydraulic circuit, and slave cylinder first, which is really easy to do. I told you can see it from the outside. If it's under the vehicle, so it's a rear-wheel drive vehicle, put it on a lift and have, who was it, Bill? It was Travis. It was Steve. Who's my porter? Jose, come get in this vehicle. I'm going to put you on the lift. Push the clutch pedal up and down, up and down. Now I'm going to get under it and watch it. If the circuit is functioning as it should, you will see the release fork travel the full distance of 3 or 4 inches. If there's air in the line, Jose's pushing the pedal all the way to the floor and it's compressing that air. It's not going to move the release fork very much. You'll be able to see it. It'll be cake. All right, do I need to go diagnose this or that? Cool. I've made a decision within just moments. So don't get hung up, don't get scared about this. Assuming that the hydraulic circuit is working as it should, then we'll go into, all right, without the engine running, see if it'll shift through gears. That'll tell me right now if it's the transmission. If it's sitting still, it won't shift between first and second. And then go ahead and depress the clutch. But with the engine not moving, if it won't shift, it's the gears in the transmission. Then we'll put the transmission shifted into neutral, start the engine, listen to it. If it's in neutral, the output shaft is not spinning, the gears are not meshed together, so they're not touching, and it's making noise. It's safe to assume that it's the clutch because it's the only thing engaged right now. Does that make sense? Then, if it's none of those things, I'm going to shift it into first and listen. If I shift into first and it's not real happy, And then I shift into second and it's fine. I shift into third and it's fine. I shift into fifth and it's fine. It's probably not the clutch. It's probably first gear. Now let's flip that. I shift into first and it doesn't go happily and it makes noise. And I shift into second and it doesn't go and it's not happy. And it's every gear that I try to shift, it's not happy. What's something that affects the entire transmission as a whole is this clutch. If it's not allowing the engine and transmission, which is really what it's doing, right? It's making the RPM of this crankshaft meet the RPM of the spline on the input shaft, become the same. So if it's slipping or it's got problems, it's not going to do that well. So a clutch will affect the entire transmission equally, whereas the much more likely, if you have grinding, this is what they always tell me, it's like usually second gear or first gear. It's either from launching hard on drag racing or people downshift into second hard, and that'll cause the synchronizers to fail for that gear set. And then, so, hey man, my car's making noise. When? Every time I shift into second, then it's not the clutch. Yes, it is. I have to push the clutch every time I shift into second. Yeah, but it only does it in second. That's the gears that form second. That's not the... Okay, you guys get the point. I'll stop preaching about that. What else do we have on there? Clutch pedal is hard to engage. So I've seen this once in my life where the finger here, broke, and then kind of got jammed. He fell down sideways and was pushing that bearing. So no matter how much force we put on the release fork, which is supposed to push the bearing into the pressure plate, the bearing wouldn't move because that finger, that spring, had broken and fallen in between them. So if you get any instance where you push that clutch pedal down and it's just impossible, it's most likely a pressure plate issue. Either way, we're pulling the transmission out to inspect it. Transmission grinds or chirps while shifting. It depends. Is it one gear or is it every gear? If you can't get the transmission to go into gear, that's more likely synchronizes on the transmission. Always do this. Turn the engine off and see if it will shift because it ought to. And the engine stalls. So this is interesting. You put it in first gear and you let the clutch out and it stalls the engine. Or you put it in first gear and you let the clutch out and the vehicle doesn't move forward. These are both your clutch friction disc, and this is going to be your most likely. The customer starts to notice it's slipping. I'm making eyebrows at you, Cody. Yeah, the customer states the clutch starts to slip, but it still gets them to work, so they don't say anything about it. And then the slipping gets worse, and maybe they misdiagnose it themselves as having a problem in first gear because we talked about this. I need way more force in first gear to get the vehicle moving. I need way less force in fifth gear to keep the vehicle moving. You're much more likely to notice slip in first and second gear. So that may be that's what they're going to say. There's something wrong with my transmission. It's messing up in first gear, not understanding that it's the clutch. Finally, when all that friction material is worn so thin that it's no longer making a mechanical connection, the vehicle won't be able to drive, which is where that Mazda I had, she had to tow it to me because she wore that thing slapped down to the rivets and ended up with a new pressure plate. Anyway, flywheel. Anyway, so that is my entire clutch here, and let's go back to my video because my question is, when this dude misses a shift, why does the car nosedive? Well, that's because these are front-wheel drive vehicles, right? The transmission's in the front, drive wheel's in the front. Why does it nosedive like that? What is happening or breaking, coming apart, causing these problems because he missed a shift? So things to consider here. We're racing, so the engine's at very high RPM. We know it's very hard to make the engine spin, right? We're shifting, that's creating different input-output gear ratios. And when I let the clutch out, it's forming a mechanical connection between that transmission, whatever RPM it's doing, and the engine. whatever RPM. Look, both of those dudes blew their cars up. Why is it all these CRXs and Civics? I like these cars. Blow up a Camaro. I'm sorry, I didn't mean it. I didn't mean it. Oh my, look, this dude's in my Subaru. Uh-oh. That wasn't bad. Oh! Oh! Don't do it! How you like the cape on that Civic? Oh! He did an endo. I know you guys love the fat tires on the front, skinny tires on the rear. Oh, I saw that. That wasn't a gear, bro. Oh. Oh, and then they died. Oh my god. I blew up my car.
Throttle shifting. Call that two-step box. Ready? First, brake the floor like this, and dunk the clutch.
Oh yeah, that's a great example of why you don't do that.
Snap the CV joint. It's a little warm. Oh yeah, CV joint is.
No, it's not,
God,
you idiot.
hurts.
CV joint. God, these idiots. Anyway. CV axle. Okay, so this is what I need from you guys. Make sure you get started on your CDX. I gave you the code. I'm going to text you all in a moment. Answer my questions by form of text message so that you get credit for this week's attendance. Next week, I don't think we're meeting in person. I think they're sanitizing the school. Next week is gear ratios in the mechanical side of the manual transmission. That means week 3 we will be in the classroom, and I have a manual transmission I think I want you guys to disassemble. So look forward to that. Everybody be on top of their CDX. You got my number. If you need me, call me. Otherwise, I will see you guys next time.